Hi, everybody. Thank you for dealing with my issues. My name is Mark Mandel, and I am a developer advocate for Google Cloud Platform. I'm sporting a Girls Make Games T-shirt. It's a wonderful organization that does education for games for making games. They do summer camps for girls. It's awesome. You should totally check it out. Fantastic. All right. So, what are we doing today? Apart from the fact that I have a cup of tea, which is the most important thing ever. And if I don't have a cup of tea, that's bad. Okay, so we're working on Agones, open source platform for running dedicated game servers at scale. And that is running on top of Kubernetes, which is another open source platform for running processes across thousands of clusters or hundreds of clusters, or potentially even just 2 or 3 machines. That's totally fine too. But open source. So... Tea-sponsored streams, big time streamer now. Yes, I'm sponsored by Lipton's. No, I'm really not. But if I don't have a cup of tea, bad things happen. Excellent. All right, so today we're still working on the thing we've been working on for a little while, which is updating fleets with new versions. And I think we were having some chats in channel last night. I think I had a bit of an epiphany, but I'll give you a bit of a demo of where things are at now. And I want to make some changes, and I think we're going to break some stuff. I think it'll be fun, and I think we'll also do some more testing. But I've been doing some more work on this, so let's switch over to here. We'll come over here. So I don't think I've already got the most recent version installed. All right, so there's nothing installed. There's no fleets. So let's install a fleet, and we'll see how we go from there. That's not what I want. Let's do this. kubectl apply-f. So I'm going to use the very simple, I have a simple UDP server. So I'm going to install a fleet. So what that does is, I'm just going to describe it actually. It creates a set of warm game servers that we can do stuff to, and we can pull out of and run on stuff against. So you'll see there's 2 replicas. So we'll actually have a look. There's like 2 game server replicas that will fire it up because we asked for 2 of them. You'll see this is new, strategy type recreate. This is the strategy for wherein what do we want to do when we change a value, or we change, like say we have a new version of our server or something like that. How do we go about pushing this change out? And right now we're just working on recreate. We're going to do a rolling one later on that's going to be very reminiscent of how deployments do things. But this is like the big bashy hammer that just says, hey, just blow it away and start again. And this seems to actually be working quite well. So hold on, let's actually kubectl. Like we have 2 game servers because there's 2 in our fleet. We can actually see there's 2 backing pods that are running there as well. And so the easy way I found of actually testing this to prove that it works to a degree is just changing the container port, because it's easy to look at. So if I do like a describe game server and I grep container, container port. Container port. Nope. Let's grep container. Oh, okay. It's got space in it. We can see those 2 are set up at 7654 or 765. Yeah, 54. That's right. So if I do say kubectl, kubectl edit fleet simple. We could give this a whole new image. Generally, I think if you're going to update, you're going to have a whole new image, which is totally cool. But the easy answer for me is actually to just say 7555, for example. All right, and this is just something I can then grab. So if I do that and I say yes, so what should happen? So I should have 2 game server sets now. Whoops, no. So a game server set sits behind a fleet. That's right. So if I say describe fleet, we can see it's created a new one. So basically what happens is, like at the same time, what it does is it scales down 1 game server set to 0 immediately, and then builds up another one straight away. So basically, it's trying to terminate one game server set. So basically 1 set of game servers, like 2 of them, and then fires up 2 of them all at the same time. What do we have? We should have a couple of them. Yeah, here we go. So this looks like the new one. It was created newer. And then this one, oh, interesting. What am I looking at? There's one. Oh no, there's only one. There's only one. Okay, because it's we look at our pods. Okay, and so that's actually flipped. So if I go describe.js, grep, container port, that's now 755. Let me think about how, if there's a better way I can explain it. And so, okay, so really, if you don't get the bit about game server stuff, that's fine. Really what happens is it basically has an interim step, but it tells all the game servers that aren't allocated to die, right? So terminate those, and at the same time fires up a set to replace them. Now it's doing it at the same time, which I don't know if I like. The reason I'm not 100% happy with that is sometimes game servers take a long time to go down, and they're still going to hold those resources, like basically CPU and memory. And what I think would be better, let me think this through. There's some interesting questions here. Maybe this is okay. Maybe this is okay. I think, yeah, some of this is me thinking through stuff. So where are we? Okay, so here. So if you want to actually, if you're actually interested, to do a recreate deployment is I basically take the non-active game server set, so the one that hasn't got the latest details in it, and just set it to 0. And then further on, I basically say, okay, any game server sets that have that are not active, which is usually what happens, right? And they have a status of replicas, right? So they only have a certain number of game servers in them. Just remove it and just kill it. So you're done. You've cleaned up. Just trying to think. Do I actually want to? Actually, I'm thinking now. I'm thinking this through some more. That I think I'm gonna leave it. Originally I was gonna change this, but I actually think I'm gonna leave it. I think I'm gonna leave it. It does use more resources, right? So there needs to be a little buffer there if you're doing a recreate, but it does mean that you can always allocate. You're always gonna have game servers you can allocate from, or very quickly you're gonna have game servers you can allocate from. It's a much smaller window. So I'm gonna leave it. And if we end up changing it down the line, that's okay too. Okay, so let's do something else that's fun. Let's try and break this thing. I think that's the more interesting thing. So the other thing I haven't tested, doing a little end-to-end test, is actually to make sure all the allocation stuff works properly. So let's look at that. So we have, all right, so we've already said, so we have this fleet. We have a fleet, and it has, let's scale it. Let's kubectl edit fleet. Let's pop it up to like 5. Let's do that. And so now if we say, look at our pods, for example, okay, so now we have 5 game servers running. We can have a look at that, kubectl, describe.js, grep, state. And we can see we have 5 of them there ready. All right, cool. Agones, is Agones aware of available resources at all times? So Agones isn't doing anything, Agones specifically isn't aware of resources at this point in time. As we get into things like auto-scaling way down the path, we'll definitely be looking at resource usage, and there's some interesting things that we can do there. I've written about this in my blog series on compoundtheory.com about managing resource usage. There's APIs and all that kind of stuff. The thing worth noting, though, is that like Kubernetes is very aware of resource usage, and whatchamacallit, and so if you try and create, say, a game server or just a pod and you've run out of memory, bad things happen, essentially. Either it won't start up. Minikube actually actively deletes stuff, which is weird. It just assumes things are stateless. It's kind of strange, that kind of stuff. Sebro asked a question. What's the difference between a fleet and a deployment? That's a really good question, too. So at face value, you might look at this and say, oh, this is the same as a deployment, except for the fact that it's not. So game servers... Game servers do this weird thing. I don't know if it's weird, but they have this interesting thing. So if you look at the Kubernetes ecosystem, deployments kind of assume a stateless system, right? So you're running a web server or something like that. If you kill it, it doesn't matter. You look at something like maybe a stateful set, and you can probably debate this point to a degree, but they believe that, you know, things are probably going to stay up for a long time, or at least the persistence, the disk persistence is going to stay up for a long time. Game servers themselves kind of transfer from a stateless thing to a stateful thing as soon as they are allocated or players play on them, right? So I could have a bunch of game servers running. Until players connect to them, I don't care. Once players connect to them, they are stateful. I need to be able to have, I need to be aware of that state transition, like as they go into allocated. And so once they're allocated and we have players on them, we cannot delete them. So if I scale down a fleet, I cannot delete or shut down allocated game servers until they shut themselves down, basically until games are complete. And that is really the big difference. There's some other little things in there, but that is the big difference. Jerry came in and said, came here just to see you say cache. People who follow me from when I used to do a lot of Adobe tech stuff. Cool. All right. So we were talking about allocations. So let's actually allocate from here and see if this thing does the thing we're supposed to do, like when we do updates and stuff like that. So if we do kubectl create-f, so we're going to do an allocation, simple UDP server fleet allocation.yaml -o YAML. So we'll pop one back out the other side. Okay, so that's done an allocation. Wait, this is the game server we got. Where are we? Here we go. So here's fleet allocation. We asked for one from simple UDP, and we now get back a game server that's instead allocated. Let's pop another one of those out. So if we actually have a look now, so we have 3 that are ready and 2 that are allocated. Okay, and those allocated ones cannot die, right? Players are playing on them. That's like, players get mad if you shut things down. So, $1 million question. I actually haven't tested this before, so this may break, and we'll see what happens. What I should be able to do is change from one to another, and change some details, and it should retain the old game server set, essentially the backing system. And those allocated ones should still exist, and then we'll see if we get some new ones. Where are we? All right, so kubectl edit fleet. Simple UDP. Oh, just as an interesting thing, if you haven't seen it before, like sometimes I write GS or rather than game server or FLT. So these are just shorthand versions of these resource names. So let's do that. So edit, scaling up and down. All right, let's change this to 6555. All right. All right. So what should happen? What should happen is we should still only have 5 game servers, which is what we have. The 2 allocated ones should not change, but we should get 3 new ones that are with the new container port. So let's see if this does what I think it should do. All right. Let's have a look at our pods. All right, 3 are terminating. Oh, this actually looks like this worked. I'm actually kind of excited. All right, so let's wait for those to completely shut down. Sometimes they take a little bit. Let's have a look at our game server set. So actually, let's do this instead. kubectl describe fleet. I want to have a look at all the things that we have going on here. So we have events that are happening down the bottom here. So here we go. So there is our scale. Beautiful. We can see we deleted that old inactive one from before, and we created a new one, glhr. Okay, cool. So that looks pretty good. If we look at our game server sets, which are basically the structure behind each one, so we have a game server set for each of the old configurations. So there's the old one. Let's have a look at that. kubectl describe the old one. Oh, that's interesting. Oh, describe. Sorry, game server set. There we go. Here we go. Oh, sweet. Here we go. So you can see that it's been updating, deleting. It's allocated replicas is 2, right? So we got it down to 0, right? That's the scale down part of things. That's cool. That's working. Replicas is 2 and allocated replicas is 2. That seems to, and it's deleted the old ones. That looks pretty good. GS set. So game server sets. Let's have a look at this one. kubectl describe GS set. All right, sweet. And that's at replicas 3, right? And that's what we want, right? I don't want the new game server set to have 5. I want to have 5, like I want it to have, because there's already 2 allocated. So I don't want to have more than 5 game servers running at any given point in time. Otherwise it could get really weird really quickly if like you do a flip and then suddenly you have, like, depending on how many you had before, you could just use up a bunch more resources. It could just get really strange. And so if I do kubectl describe gs grep state, I should have 2 allocated still, 3 ready. Beautiful. And then if I do a describe gs grep container port, I wasn't sure whether this is going to work. Sweet. So we have 2 We have 2 that are in 7555, and then 3, which are the new ones in 6555, and those old ones are allocated. So let's play one more game, which is let's shut down one of the game servers that are in an allocated state, and we should see it transfer over to the new version. Let's see if that works. This should be cool. Hopefully this works. This is nice. Hold on. All right. What's the easiest way of finding this out? Let's find this out through... Actually, the easiest way of finding this out is that we can actually look at the timestamps from these game servers. Let's look at this one. Let's just kubectl describe GS. Let's have a look. All right, so that's one of the allocated ones. So let's just delete it. Delete GS. So we can do that. All right, so that's deleting. So we actually have a look at our pods. We can see that's shutting down. Okay, that's terminating. Excellent. All right, so what then should happen is the system should actually increase the number of the new inside the other game server set, and whatchamacallit, and then we should get the next one. Let's have a look. Get pods. Okay, that's still terminating. Okay, while that's terminating, I see there's a question. How would container ports be used? Or the question I might really be asking is, what are container ports? Oh, I see. That's a good question. So container ports are very much like anything you would have used general Kubernetes container ports. It's basically saying which port inside the container is the game server running on. And so basically then the system knows how to route outcoming traffic or incoming traffic from outside into that container. So the container itself doesn't need to know what the outside world is doing. It just says, oh, I'm going to start up on port, 7,000 or 8,000 or pick a number. And then it's gonna continue on from there, and then it does the work for us. Okay, cool. So, cool. We have 5 running pods. Excellent. That looks good. Let's have a look and see what all the events look like. Describe fleet. Yep. Oh, look at that. Perfect, right? We scaled, like that died. So then we scaled the game server set, the active game server set from 3 to 4 because we wanted one more. Awesome. This is actually doing exactly what I wanted. Oh, I'm so happy. This is really, really neat. All right, cool. Yeah, and Afraid Duchess, this is a good point. Like the container port stuff inside Agones is exactly the same as the container port stuff that you would use in regular Kubernetes. It's literally just leveraging Kubernetes constructs to do that routing. It's really, really straightforward. So if you're going to do a deployment or anything like that, you're doing exactly the same thing. There's really no difference. All right, so that's moved up. That's done the job. This is so neat. All right, cool. kubectl. All right, so kubectl. What do I need? I just want to. All right, so then finally, why don't we? kubectl get GS. I want to kill the last one. Let's do that, and then we should actually see the game server set. We should only have one game server set. Let's left. And then I think delete. No, why is that not found? Delete. Oh, sorry, not GS set. It's a game server. Let's do that. Okay, there we go. So what should happen now? That should go away. Right now, we have 2 game server sets that are running behind it. One with the old version and one with the new version. And this should... We just need to wait for that to terminate. Yeah, I was going to change all this. And you know what? I've come back around, and I don't think I will. This is probably the simplest implementation. The theory I had before was I would do it so that once a pod was done, like once a game server was done terminating, like it was all shut down, then I would replace it at that point in time. But I kind of don't like that, just because what would happen is there would be a really longer gap. Like basically all the non-allocated game servers would be killed, which means you can't connect to them. And then we would wait for them. Well, they get a termination signal, which means essentially they're dead. I mean, for all intents and purposes, right? Even if a player connects to them, they're only going to get shut down. So that's bad. And we don't want them doing that anyway. So we might as well start up a bunch straight away. So I think, yeah, this makes me happier. It probably uses a bit more resources, but I'm happier with the decision. Okay. So pods are all up and running. So if I look at GSet, I should only have one of them, which I do. If we have a look and we describe our fleet, yep, we deleted the inactive one and we go from 4 to 5. Awesome. This actually did exactly what I wanted to, and I was really happy. I hadn't actually tested this yet. Okay. In which case, we will work on some other things today. Let's have a look and see what's on my to-do list. I think we're going to be working on setting some defaults. That we don't care about because that's a to-do that is in some generated code that I can't get rid of. Ooh, let's do this. Actually, there's a no, I'm not going to do that. Just if you use the linter, I've got a cyclomatic complexity. Basically, this function here is too complex. I need to chunk it up a bit. But that's not as interesting. So I'll do that later. I'll do that myself later. Let's, I've done this before, but you know what? Let's do some webhook stuff. I need to apply some defaults and, we'll continue on from there. Agones development is complete. It is not complete. So the thing that I am facing right now is that, we actually don't have a default strategy. And so I want to create one is the short answer. Nothing too crazy. We've kind of done it before, but it needs to get done. So let's do it. So where will we start? So not there. So we have a convention that we've used before. So we're basically just going to copy it. So if I have a look at game server, I'm just going to close others. That'll make life easy for myself. So we've called it apply defaults. That's probably a half decent name. So let's continue with that. And inside a fleet, here we go. So let's create a function called apply defaults. Applies default values to the fleet. F pointer to fleet. Cool. No params. It's not going to spit back anything else. Nope. Cool. And what else do we want to do here? Okay, so really all we care about is if f dot spec dot strategy. Now this is an interesting one. Yeah, so if this is a deployment strategy type, what does this actually come through as? Which is a string. So it's going to have a default value of empty string. Strategy dot type equals blank. Then now the interesting thing I think maybe somewhat interesting is that I think eventually once a rolling update is ready to go, that'll become the default, but better to have a default at least to start, and then we can move it on from there. So f.spec.strategy.type equals recreate. I don't like v1 as a name for anything, so let's give that an import alias of apps v1, and that's a bit better. Yeah, that's really it. I don't think there's any other defaults I want to apply to a fleet. Where are we? Fleet spec, replicas, nope. Replicas by default will be 0, and I don't care, so that's fine. Although I think I actually have it specified. Where are we? Let's actually have a look in the. What's my validation look like? Fleet.yaml replicas. Replicas is required. Should be an integer with a minimum of 0. Okay, that's fine. That's good. So that's actually got some client-side validation in there, so I don't have to do a lot. Cool. Spiffing new buns. Watching you code is such a therapeutic thing. Oh, that's nice. I'm so glad to hear that. I appreciate that. That's really nice of you. I'm curious to know why it's therapeutic. I'm very curious about that. All right. Let's write a little test for this because we have to test everything. Testing is important. Test fleet apply defaults. I don't know why IntelliJ or Golang, whichever one, like the plugin, puts an underscore in on the default here. It kind of annoys me. But here we go. So let's actually just create a fleet. I actually don't care about the details. Let's just actually check the gate. Cert.empty tf.spec.strategy.type. That should work. And then f dot apply defaults. Boom. Gate just says this is what I expect it to be to get started. So let's just double check that, make sure it does what it should be doing. And actually, let's make it a pointer. There we go. That's a bit better. And so now assert dot equals. It's really nothing special. Recreate. Oh, it doesn't like that as v12, which is apps v1. And that should be f.spec.strategy.type. Yeah, IntelliJ is kind of weird. If there is already an import alias, if it adds an import alias because it can't do v1 again, oh, that needs changing. That should be meta v1. But anyway, I'll get back to that. Yeah, it lets you rename it, but otherwise it's like it does really strange things. All right, that should be pretty straightforward. Assuming everything runs okay. Here we go. After a long day of coding, watching code appear before me without doing much of the thinking is therapeutic. I love that. Google I/O. Yeah, I think, no, the keynote starts at 10 a.m. Yeah, 10 a.m. And then the developer keynote is, I want to say 12:45 Pacific off the top of my head. And so people, will you all be roaming the place? I will not. I'm at home. I'm sure there are definitely other Googlers floating around. I am not at I/O. If I was at I/O, I probably wouldn't be doing this. All right. Should be empty, but was blank. Why is that not? Yeah, that's really interesting. Okay. Out of curiosity, why did empty not fail? Empty asserts that the specified object is i.e. nil, blank, false. What was it then? What if I just say equal instead? Which should be the same, right? Expected blank, but was actual blank. Oh, I know why. I know why. Because the type systems aren't the same. But I can do equal values. Because I'm lazy. There we go. So the difference is strategy.type is actually a deployment strategy type, which is a type alias for a string, but the testing thing will say, oh, these are different. They're different. Where was I? They're different types, and therefore I will fail because that's really what it should be doing. And so if we do equal values, it's a bit of a looser type comparison. It'll do introspection and whatever magic it does. Basically, it's the same. I could also cast it. That's probably better, but I'm feeling lazy. Cool. All right. That's a good start. Let's commit that because good committing practices. Shall we go imports /w? You run go imports. Make sure that's good. Yeah. Sweet. That all looks pretty good. Nice. All right, so this is apply defaults function for fleets. Lovely. All right, good committing practices. Excellent. Okay. Now I'm gonna do all the work for webhook stuff. That's okay. I can do that too. Where are we? So mutating webhook. Let's set this up. So what have we got going on here? So the mutating webhooks are, it's a webhook that that intercepts, I should put it that way, intercepts when things happen inside a Kubernetes cluster to resources, and you can mutate them, strangely enough. I've got some plumbing code that already does some of this work for basically routing this configuration through to appropriate places in code. So I don't have to do a lot of this work other than, let's make it fleets. So we can edit that here. We can do, okay, cool. API versions 0.1. So basically whenever any of these three things get created, I want you to intercept them. So I've already done game servers and fleet allocations. So that's applying defaults and stuff. So I want to do the same thing for fleets. I could be really lazy and just grab the code I wrote for game servers and probably just copy it across, and it will probably be fine. Let's do that. I think maybe down the line, what I'll end up doing is, whatchamacallit, probably doing some more work on the plumbing side of this things to make things a little bit easier. But we'll see how we go. We'll see how we go. All right, so I need a webhook. That's a good start. Let's have a look. All right, so close others, and I want to look at the fleets controller. There we go. Put these next to each other. And then we can basically just copy the work that I already did. All right, fleets controller. I don't need that, but I do need the webhook. Do I usually put it before? Okay, so that's the same. Good, good, good. All right, so the webhook is like my little bit of plumbing code. You can actually see it in the Agones repository. Like we can add handlers and that kind of stuff, and basically register listeners for events as they come through. It makes life easy. I wanted to have that. So blah, 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 worker queue, webhook handler. Okay, beautiful. I'm going to steal this. And where do I normally put it? I usually put it after the worker queue and the health checking. Beautiful. There we go. There's my to-do, right? Beautiful. So I can just go blam. Excellent. So I don't want... I'm going to register the path mutate with the kind fleet, which is what I want. I need it to be create. I'm going to... No. Go back. No, go back. In the import. Oh, I'm looking at the wrong one. I'm silly. Up. There we go. I want that. I try and be consistent with my import aliases as much as possible. Well, I'd like it to be consistent across everything. Okay, cool. So fleet, beautiful. That's what we're looking at. We're looking at just create, which is also nice. And we will register creation mutation handler, which I don't have yet. But what I think I can do is basically just copy the one from here, creation mutation handler, and then just futz it so that it works for fleets rather, because I've got the same name. So here's an interesting thought. Since I have a standard function name for applying defaults, I could potentially turn that into an interface and make this generic. It's an interesting idea. I'm not going to do that now. I would rather do that as a separate thing. But what I'm going to do is actually write a note to myself. Can we make apply defaults mutation webhook generic and remove some code? I like having a little. I have a little to do that's like outside of tickets. I know I probably should maybe make these tickets, but these are like, can I do this thing, or is it a little thing, or I need to explore it, and it gives me some ideas to play with. Okay, so I'm not going to do that right now. Where do I usually place that? So I place that creation mutation handler right after run. No, right after the new controller. Okay, let's just, we'll steal this. I also tend to, at least personally, this is just like my thoughts. If I copy paste something twice, I'm like, meh. If I do it 3 times, then that's the time I like to go back and really fix things. But I feel like this is probably a pattern that we're going to see a lot. Okay, JSON, and also this is, encoded JSON, yes, beautiful. There are probably places within this plumbing code that I do a lot of. Like it's a lot of the same thing, and I probably could be a bit more opinionated about it. To do red test. Creation mutation handler is a handler for webhooks that sets the default value on the fleet. Fleet creation operations. Okay, cool. I do a lot of logging here, and I feel like I probably should actually do less because I actually logged the whole review. But you know what? We're fine. All right, so this now should be a fleet. Yep, do that refactor. Beautiful. And we want to make that a fleet. All right. So what you get in here is what's called an emission review, if you're at all interested. An emission review is basically a JSON blob. There's a bunch of data about what's happening, plus a JSON blob of what's coming through, and it's on you to change basically the JSON document as it comes through. That's what you're intercepting. You're not really intercepting the resource per se. It's actually the JSON data that comes through, which is interesting, which is actually quite interesting. And it's an interesting perspective on how this thing works. So we get basically object.raw is the requesting object that comes through. That's the thing. So we can unmarshal that ourselves into an actual object. And this is the fleet JSON. Excellent. Fleet.apply defaults, which is what we do. We want to call this a new fleet. All right, so which is the new JSON. I don't know, I like that as a name, but anyway. But that's okay. New fleet, yeah, that's not terrible. So we turn it into JSON. And then what we do is we create what's called a JSON patch, which is basically just a bunch of commands. It basically says add this value here, change this value here, remove this value here. And I use a library, JSON patch, to do that. It makes life easy. So I can just basically compare two JSON objects, and then it does the work for you, which is sweet. This really hasn't changed that much. Here we go. Game server should just become fleet. I really feel like there is really good opportunity here for making this much more generic for like these common type operations. Because this is, yeah, I'm doing this a lot. And at the very least, I could make a function factory, or not function factory, or a function creator that creates the function that fits this review. But really the only thing that comes through is that. Even then, actually, let's think this. The problem though is type systems inside Go. Is this? It would need some kind of maybe marshal or an unmarshal type thing. I don't know. I'd have to have a look at it. It'd be an interesting one. It'd be an interesting refactor operation to see what's possible and what's not. Just because the type system for Go is quite simple. And we're not going to know exactly what this type is unless we're very particular about it. But we could probably do some neat stuff. Anyway, I digress. Anyway, so that all looks pretty good. Fleet, error. It's all pretty much the same. Let's actually just take the test from over here as well. I think that's probably pretty straightforward. Create. Here we go. Creation mutation handler. There we go. I'm gonna steal it. And controller test. Here we go. And I broke a bunch of stuff too. Okay, cool. Which is fine. All right, so I broke a bunch of stuff. There's that too. Where do I want to put this test? I'm gonna put it. Not that it actually really matters a great deal. There. All right. All right. So this needs to be a fleet. I need a default fixture. Actually, I don't want a default fixture. Because we'll set that as default in a minute. Let's just have a fleet, then an empty fleet. Creating JSON, beautiful. Let's just do that. It always does that. Let's make that a where v1 import alias of there. Let's go back. Okay, cool. Emission create kind is of type fleet. We created that before. Kubernetes has, you've seen that in the oh my god, first thing in the morning. Custom resource definition, we have there's a group and there's a kind and there's a version. So this is group stable.agones.dev, I think off the top of my head, and then the version is v1 alpha 1, and then the kind is of kind fleet. So there's combinations there. Cool. We just want to see, okay, so we actually create everything. We create a fleet. It's got nothing in it. And then what is this doing? Interesting. Could not find operation. Assert contains. What does it do? Oh, interesting. It goes through the patch and finds a bunch of stuff. Ah. Interesting. The only thing I will want it to do is strategy. That looks like a function that should probably get pulled out into something that's a bit more generic. But that's all right. Spec strategy. I'm willing to bet this is right. We'll see if I get this right. We'll see if it... And it should set it to recreate. Now, there is one small thing that is broken, which is I added an extra argument to here. Yeah, you can see I need to fix that, but that's okay. And that is I need to pass in a webhook. So I assume there's nothing special I do on the fake controller. Nope. Cool. I just drop one in. Controller test. So let's create one. Now it's happy. All right, let's see if my test passes. Or if I broke things. What did I do? Create. Creation mutation handler. Here we go. Running. Let's see what happens. Compiling. Let's see if I got that actual, that JSON path. Yeah, I got it right. Oh man, that was pretty good. So actually, if you want to see what a patch looks like, if you haven't seen one before, this is literally it. Where are we? Scratch file. Let's dump that in there and unescape JavaScript. There we go. So this is like a one spot JSON patch is what gets generated here, which is kind of neat. And so you can see here we're adding a value, the path to the value, and then what value to add. That's really it. And then you just have more and more and more of them. So that actually did what I want. Let's see if I broke any of the other tests. Run controller test. Compiling. And so far, everything's green. All right, sweet. All right, let's see if this works. Let's come back. So that's deleted. Let's make build images. So let's run that and build a version. Actually, that'll be fine. I was going to commit it first, but that's okay. I think that's going to be fine. Because we have a new version coming through, or we can hack it. All right, that's fine. So then let's go to where are we? Examples. That's what I want. Simple UDP server fleet. So in theory, we should be able to delete this because now we have a default, so it should just work. Whoop! Something died. Whoop, there we go. Not enough arguments to call in fleets.newController. Ah, yes, that is true. All right, so things broke. Controller, main.go. Yep, see, that's bad. So let's do that. And since we're in here, go import /w package, and let's also do command. Since we've tweaked both of those. Oh, nothing special happened in here. Nope. Okay. Oh, a little tweak. There, that's all right. All right. Let's try building it now. Actually, let's commit this. First pass at defaults for fleet. Cool. I like to build, well, I like to commit for two very, very good reasons. One, small commits, yay, that's good. You can always change your Git history. That thing is very malleable. And I do that on a regular basis. Second thing, my build process actually uses the hash for from the commit to tag everything, including the images and all the way through for development. So actually you can see that here, right? So for example, I'm building and you can actually see I'm pushing through a version through to the Go code. That's part base version, which is what the next version is, plus the short hash of the Git of the Git version, so that I can actually see first of all what I'm running, but also it makes it easy for Kubernetes to be like, oh, this is a totally new version. I will make sure to push up to update everything that needs to be updated. So that works quite nicely too. All right, so the theory being, once this is built, I should be able to create this fleet that doesn't have a deployment strategy attached to it, and in which case it should work. And if it works, I think I'm probably going to stop there because I do have a meeting in 10 minutes that I need to be at. That people tend to be, it's an important one. Let's put it that way. Oh, I can get rid of that line because I wrote the test. Anything else that I need to do and clean up while that's going on? Let's have a look at our to-do screen. All right. I did that, so I can get rid of that one too. I need to fix that cyclo. I need to do that. I might leave this in here inside the Synotic one just because it's nice to have an example. The other thing, ooh, you know what I don't have, to be completely honest? Not Synotic, but the full example does not have this in here. So let's actually add that. Let's make sure that that is in here. And the other thing to do, write some docs for this. Just making a note there because I haven't actually written the docs for Recreate. So I need to do that as well. All right. That's running through, that's saving, that's pushing up. Let's see if this works. All right, sweet. That is now installed. Let's make sure there's nothing major going on. Everything, I don't see any errors coming through on the logs. Cool, I can see the webhook handler is happening for fleets. All right, let's create a fleet. So let's actually double check that real quick. I might leave this here just to have an example. I just like leaving little examples around. Simple UDP, but on this one, this is the one I want to test with. So there is no strategy. All right, cool. Apply-f examples, simple UDP server fleet.yaml. Boom, created. See if there's stuff. Yeah, that worked. Beautiful. So you describe it, we can see the strategy is recreate, and I didn't have to do anything. That's actually super nice. If we want to actually have a look at our logs, namespace Agones, if we grep, oh, here's a fun one. Where are we? Fleets. Yeah, grep fleets. Controller. And we have a look. Here it is. Beautiful. Creation mutation handler. We can see the route that came in. We can see that a patch got created. That's pretty sweet. Oops. Let me scroll back up. Here. Okay. Creation mutation handler. Yep, that came through. And then we did the things that we're supposed to do. We actually applied default. That all works swimmingly, which is quite sweet. Awesome. I'm going to drop that line out of there. Excellent. All right, so now we have defaults. That's lovely. Was there any other to-dos that I needed to drop? I don't think so. All right. Git commit some cleanup of to-dos, etc. That's fine. And I'll push that up. All right. Wonderful. I'm going to wrap things up here, just finish up a little bit early on this stream today, just because I've got some other stuff I need to get working on. But I just want to say thank you very much for hanging out. I had some really good questions in chat today, so that was really cool to have those and get some really interesting discussion happening. I thought I was going to break more things than I broke today, but actually things worked really well, so I was having a really good day. So I can't complain about that. Like I usually say, today 9 a.m. Pacific is my usual streaming time. I will be looking at doing some more impromptu sessions during the week as well if I can, assuming I have time. But yeah, that's going to continue on as always. Follow me on Twitter at Neurotic, on Twitch, which you're already at right here, and I'll make sure to put out announcements when I'm going to plan on doing those things. If you want to go back, everything is on YouTube. You can see the link below. If you want to learn more about Agones, there's also links below. Come join join us in Slack. Come join us on the Hangouts. Come join us on the Google group is what I should say. Come join us on GitHub. Always looking for more people who are interested to come and hang out with us and do some more work on Agones, or just try it out and see what works for you and what breaks. Try and break it. Please come try and break it. Awesome. Well, have a great week, and I'll talk to you all later. Thank you so much.